Welcome to AI-enabled car parking using Opencv project demonstration. This project is guided by industry mentor Hari and P. Sai Manish, along with the faculty mentor D. Sanya. This is the content of our video. Car parking is a common problem faced by drivers in busy urban areas. Finding an available parking slot can be frustrating and time consuming, especially during a peak hours. But what if there was a solution to automate the parking process and helps the drivers finding a parking space more easily? Let's hear the rest from Bharat. I will be back in explaining the project flow.
Now we are going to see the abstract of our project. The car parking is a common problem in busy urban areas and cities. We can solve this by using AI-enabled car parking system using Opencv, which provides a solution to this problem by automating the parking process. We aim to improve the accuracy and the efficiency of the system by training a neural network to detect and recognize parked cars in real time. Introduction, which tells about the car parking, is a daily challenge for drivers in busy urban areas. It can be really frustrating and time consuming work to find a free space to park a car, which can be easily done using AI-enabled car parking using OpenCV. Provides the solution to this problem by automating the process. The system mainly uses a camera and OpenCV library to capture a live video footage of a parking lot and detect the empty parking spots which display on them in the user interface so they can easily detect the space and park the car. However, the accuracy of the system can be improved by incorporating deep learning algorithms. The problem we are facing in here using OpenCV is provides a solution to the car parking problem, but still the limitation in terms of accuracy and efficiency. The system can detect empty parking slots, but cannot recognize the parked cars accurately, which leading to this the default detection empty spots. The system also has difficulty in detecting low light conditions. A nicely neat proposed solution we are giving is the existing AI-enabled car parking system by incorporating deep learning algorithms. Specifically, we can aim to train a neural network to detect and recognize cars in real time. On large data, which can we train this neural network in a large data set of car images, and we will learn to accurately detect and recognize cars even in low light conditions. The requirements we need in this project mainly are Intel microprocessor. You can use i3, i5 or i7, we can use whatever. And the RAM we are using is minimum SB 8 GB or more than that. And the hard disk need to be 1 TB or more than that. And the camera for live video footage. These are the hardware requirements, and the software requirements are operating system. Obviously, we can use Windows or Linux. The language you need to use is Python. On the Python libraries we can use OpenCV, TensorFlow, Keras and Flask. The next topic we are saying is technical architecture, which the video input first goes to and then changes into frame. The OpenCV gets it and then scan with this UI and then using the IBM database we have and then deliver it to the output to the user interface.
This is our project flow. Our project flow consists 4 steps: data collection, neural network training, integration with the OpenCV, testing and evaluation. So let's see the working of our project. So this is the working of our project. Let me explain our project works in actual code. Let's see the project structure. So this is our project structure, our project folder structure. Next, this is the milestone of our project. So it includes a data collection, creating a ROI, video processing and object detection, and application building. Now let's walk through the project flow. First, we create a Flask application that provides a user interface for logging in and viewing the parking slot visualization. Then we set up the OpenCV environment to analyze the video feed from the parking area and detect the vacant parking slot. Next, we integrate the Opencv script with the Flask application to showcase the vacant parking slot on the UI. Finally, we test the application by logging in and accessing the parking slot result page and verifying the displayed information. Now let's see the project structure. Project structure consists of different folders including dataset, templates, statics, model building. These folders contains the necessary files and resources for building the Flask application and implementing the computer vision algorithm. Here the data collection is an important step in this project as it involves gathering the informations or data from the various sources for analysis. ROI, which stands for region of interest, refer to specific rectangular portion of the image or video frame used for processing or analysis. To create a ROI, we need to deploy a Python file. In this file, we import a required packages such as Opencv and Pickle. Then we define the width and height of the ROI and provide the functionalities to select and deselect the ROI. The selected ROI values are stored in the file for future use. Next, we see the video processing and object detection. Video processing and object detections are crucial steps in the project. We capture the video input using the Opencv and load the ROI file created earlier. Then we check for the parking space by processing each frames of the video. Then we count the pixel in the ROI and determine if the parking space is vacant or occupied. Then the result is displayed on the video feed. Next, we will see the Flask application building. So building the Flask application involves creating HTML pages for the user interface and writing the Flask code to handle the server-side scripting. We import the necessary libraries and define the routes for different pages of the web applications such as login pages and parking slot page, register page, about page, home page, like that. And the user inputs are processed and the corresponding actions are performed such as user registrations. Now let's we see the output of this code. So as you can see, this is our web page. If I click the get start button, it will take me to the login page. If you are a new user, you can register, but I already registered, so I am inserting my necessary credentials. So I log in, so it take me to the model page. In this page, if I click here button, it will show me the available parking slots. So as you can see, so overall 69 slots are available, so out of which 15 slots are empty slots. So this is our project output. Let's hear the rest from Ilangeshwaran.
Advantage of AI-enabled car parking using Opencv. Automated parking system which eliminates the need for manual intervention in identifying empty car spaces can be easily scaled to support large parking lots. Saves time for drivers looking for parking spaces, leading to reduced traffic congestion. Disadvantage of AI-enabled car parking using Opencv requires significant process power and hardware resources. False positive or false negative may occur in situations where the system incorrectly identifies a parking spot as vacant or occupied. Future scope of AI-enabled car parking using Opencv project can be further enhanced by integrating it with technologies such as machine learning and deep learning. Additionally, the project can be extended to include features such as reservation-based parking. In conclusion, the AI-enabled car parking using Opencv project provide an innovative solution to the common problems of finding parking in busy urban areas. Overall, the project provides a solid foundation for future development and expansion, and it has the potential to the parking industries with its innovative use for technology.
So thank you for watching. This is our project demonstration. We hope we did our project demonstration well. So thank you.